Good day, students. Welcome to math.surf.com. In this clip, we're going to be going over some review problems on right triangle trigonometry. All right, let's take a look at question number 1. Given this right triangle, we're to find the value of angle theta. Okay? All right, so to do this, we have two sides and an angle. Whenever you want to solve the measure of an angle, given a side or two sides, you can make use of right triangle trigonometry. So you're going to be using SohCahToa. SohCahToa basically shows the relationship between an angle and the ratio of two sides. So we already have the angle under consideration here, namely theta. So we need to figure out the label for these two sides in order to set up a ratio. So if this is theta, the side that's opposite theta, this side right here, is the opposite. All right. The side opposite the 90-degree angle is the longest side of the triangle, that is the hypotenuse. And the other side is the adjacent. Now in this problem, we just need the ratio of two sides. We know hypotenuse and adjacent, and the unknown is the angle. So opposite doesn't really play a role in this problem. So the question now is, which ratio relates adjacent and hypotenuse? If you look at SohCahToa, cosine tells us that the cosine of the angle is equal to adjacent for A over hypotenuse. Okay, so we're going to apply that here. So cosine theta is equal to the adjacent, which is 7, divided by the hypotenuse, which is 15. Now to get theta isolated, we have to undo the cosine of theta. We're going to make use of the inverse of cosine, which is the arc cosine function. So we'll take the inverse cosine or arc cosine of both sides of the equation. This is the only way to get cosine undone. Do not try to divide both sides by cosine. That's inaccurate. You take the inverse cosine of both sides. On the left side, inverse cosine and cosine cancel out. You're left with theta. All you do is plug in this expression into your calculator to find out what its value is equal to. If you plug it into your calculator, you would end up with 62.181 degrees, but to one decimal place, we just round it up to the 10th place. So theta is going to be 62.2 degrees to one decimal place. So our answer for number 1 is option letter B. Okay, let's take a look at problem 2. It's similar to problem number 1. So let's see here, we are to find theta again. Now we're using the ratio of sides and relating it to an angle, so we're going to be implementing SohCahToa. Now this is the angle under consideration here, theta. So let's label our triangle accordingly. This is theta. The side that's opposite that angle is the opposite. The side opposite 90 degrees is the hypotenuse. And the other side is the adjacent. Okay, so now what trig ratio are we going to use? We have one unknown, namely the angle, so the ratio of the two sides must be known. We cannot make use of hypotenuse here, since we do not know what it is. We're left with A and O. What trig ratio relates the adjacent and the opposite? The answer is tan. Okay, the relationship is tan theta is equal to the opposite of theta divided by the side adjacent to theta. Okay, so let's apply that here. We have tan theta is equal to the opposite, which is 8, divided by the adjacent, which is 4. All right, now how do we undo tan? We can undo tan by taking the inverse tan of both sides, okay? Or you can also call it the arc tan. So the inverse tan of the left side will help us undo that tan function and leave theta isolated. Whatever you do to the left side, you do the same to the right side. So you do the inverse tan of 8 over 4 can be simplified to 2. On the left side, tan and inverse tan neutralize each other out. And we just simply plug this into our calculator, the arctan of 2. If you plug that into your calculator, you get 63.434 to 3 decimal places. If we want to round it to the nearest tenth, we are going to have 63.4 degrees. Answer is option letter E. Okay, let's take a look at number 3. For question number 3, we are actually looking for a side length this time. For number 3, we are to find x. Okay, now the angle given is 17 degrees. We're also given this side and x. So the question is, what ratio relates this angle 17 degrees with these two sides? We're going to be using SohCahToa to help us identify the two sides under consideration. We're going to label this triangle relative to angle B. Okay, so this side opposite the angle right here, side little b, that's the opposite. The longest side opposite the 90-degree angle is the hypotenuse. Okay, this is the side I need. This is the side I know. I know the value of this angle, so we don't actually need the adjacent for this problem. Okay, so what's trig ratio relates opposite and hypotenuse? The answer is sine. Okay, because sine theta, according to SohCahToa, sine theta and so piece as opposite over hypotenuse. All right, so let's go ahead and set it up. We have sine theta is 17 degrees equals the opposite, which is 16 divided by the hypotenuse, which is x. To get x isolated, we have to first address the fact that it's in the denominator. So we can multiply both sides by x. So we have x sine 17 equals 16. The x is on the right side, divide out. All right. Now to finally get x isolated, we divide by sine 17. Sine 17 is a package. They come together and they go together. All right, don't try to break it apart by dividing by sine or something strange like that. Just move them together as a package, okay? So on the left side, sine 17 divides with sine 17, you're left with x. Now you just simply plug in 16 divided by sine 17 into your calculator to get the final result. If you plug it into your calculator to 3 decimal places, you have 54.724. And if you round it to the nearest tenth, x is going to be approximately 54.7 units. Answer is option letter E. Okay, let's take a look at number 4. It's similar to 3. In this one, we have to find x again. We are going to be using SohCahToa since it relates the ratio of two sides with an angle. We're given two sides, one known, one unknown, and an angle, namely 69 degrees. Okay, so let's go ahead and label this entire triangle relative to this side. This side opposite the given angle, this is the opposite. The side opposite 90 degrees is the hypotenuse, the h in SohCahToa. And then this side right here is the adjacent. Now, we need the adjacent. We know the hypotenuse and the angle, so the opposite doesn't play any significant role here. Now, which trig ratio has h and a? So, Ka or Toa? It's Ka, right? You have cosine theta is equal to the adjacent of the right triangle divided by the hypotenuse. So let's apply this Ka piece to this situation. Cosine of the given angle theta is 69 degrees is equal to the adjacent, the unknown side, divided by the hypotenuse, the known side. To finish this off, just simply multiply both sides by 9 so that x can be isolated. On the right side, 9 divides out. So you have x is equal to, so plug in 9 cosine 69 into your calculator. If you plug it into your calculators to 3 decimal places, you have 3.225. But if you want to round it to 1 decimal place, so the nearest tenth, you have 3.2. The measure of side x is option letter E. All right, so for question number 5, we are to solve triangle ABC. Now, we can work smart with this problem and just focus on the options that are different, namely measure A and measure B, to hasten the process. But let me just find C just to review an important concept with you, okay? So to solve this triangle, let's start by looking for C. So to find C, that's an SSS problem. If you have a right triangle given 2 sides, and you have to find the third side, I call that SSS. In this case, you are going to use the Pythagorean theorem. Okay, so let's call this little a, call this little b, and then little c is what we're looking for. The formula that relates the 3 sides of a right triangle is the Pythagorean theorem: a squared plus b squared equals c squared. We're going to plug in the values that we know and the values that we need will be left as variables in this equation, and then we'll solve for the unknown. Okay, so a is 10. 10 squared plus b is 10. 10 squared equals c squared. 10 squared is 100 plus 100 equals c squared. So c is basically the square root of the sum of these two numbers, the square root of 200. To 3 decimal places, if you plug this into your calculator, c is approximately 14.142. But if you want to round it to the nearest tenth, side C is going to be 14.1. Okay, so we see that we still have all the options valid. Now let's move on to the distinguishing measure, which is angle A or angle B. So if you notice, all the A's and B's are different. So let's find the measure of angle A. Okay, so if we want to find the measure of angle A, that basically means we're going to label this right triangle relative to angle A. So this is angle A. That means that the side opposite this angle that we're considering is going to be your opposite. The side opposite 90 degrees is always your hypotenuse, and the other side is the adjacent. Now, since A and B are already given, they are not approximate values, it's advisable to use those results. So we're going to be working with the adjacent and opposite. Now, if you take a look at SohCahToa, what trig function relates the adjacent and the opposite? The answer is tan. Okay, so we're going to set up the equation. Tan of A, the unknown angle, is equal to the ratio of the opposite over the adjacent, 10 over 10. Okay, so we have tan A is equal to 1. Now, how do we get A isolated? What we'll do is we take the inverse tan of both sides of the equation. We're not multiplying. What we're doing is we're taking the inverse tan. Okay, so the inverse tan of both sides. Plug that into your calculator. The inverse tan of 1 is 45 degrees. Okay, so we can clearly see that our answer is option letter E. Now, let's say you wanted to find, if this were free response questions, for example, and you want to find the measure of angle B, you can use SohCahToa to find it, but a much easier or effective method would be to implement the triangle angle sum theorem. Okay, angle B is simply the sum of all the angles, 180, minus the sum of the other two angles, 90 plus 45. Right? And if you plug this into your calculator, you're going to end up with 45 degrees as the measure of angle B. So we see that the answer is option letter E. Okay, so for question 6, we are to solve triangle ABC again. So solve triangle ABC. In this case, we're given an angle and a side. All right, so what's the quickest angle to, what's the easiest way to find the angle or the quickest measure to determine? The quickest measure to determine is angle A. All right, so to find angle A, I'm going to use the triangle angle sum theorem. Angle A is 180 minus the sum of the other two sides, 90 plus 59. Okay, if you plug that into your calculator, you end up with 31 degrees as the measure of angle A. Now, if you notice in your options, that's not an optimal variable to determine because all the A's are the same. We need to focus on a side that's different. Now, if you look at the little A's, you have a repetition here. So the best thing to find would be side C because they are all different. Okay, so let's find little c. So if we want to find side C, let's label it first. This is little c, this is little b, and this is little a. Now, the question is, what trig ratio are we going to use to find c in SohCahToa? You must remember that SohCahToa is relative to an angle. So the question is, which angle do you want to work with? Do you want to work with A or work with B? Whichever angle you work with, that is the angle you use to label the entire triangle, and you still get the same answer regardless of the angle you select. Since 59 is provided for us, let's just use that one right there. So I'm going to use 59. If I'm using 59, that means that the side opposite it, little b, that is the opposite. Okay, and then the side I'm trying to find is C, so that's a hypotenuse. So let's just do two sides at a time so we do not get confused. Now, what trig ratio relates opposite and hypotenuse? The answer is sine. In so, we know that sine is opposite of a hypotenuse. So sine of the angle, sine of 59, is equal to the opposite, 21.6, over the hypotenuse, little c. Now, how do we figure out what little c is? Multiply both sides by little c. You always do that if you have a variable downstairs. Plus the numerator. C sine 59 is equal to 21.6. Another thing to note is whenever you're multiplying a trig term by a number or variable, you put that number or variable before that trig term. Okay? To finish this up, we'll divide both sides by sine 59. And little c, we just plug in this into our calculator. You end up with 25.199. Three decimal places. If we want to round it to the nearest tenth or one decimal place, it's going to be 25.2. That's the only C option that matches what we got. So we see that the answer is option letter E. All right, let's take a look at problem 7. For problem 7, we have to find cotangent theta. So we know what SohCahToa is. SohCahToa. In SohCahToa, sine is S is for sine, C is for cosine, and T is for tangent. But we know that cotangent is related to tan. Cotangent is a reciprocal of tan. So if tan is from toa, opposite over adjacent, that follows that cotangent of theta is the reciprocal, which is adjacent over opposite. All right? So in this triangle, we're going to label it relative to theta. This side opposite theta is the opposite. The side opposite the 90 degrees is a hypotenuse, and then the other side is the adjacent. So if we look at the ratio we have here, we can clearly see that we need the adjacent and the opposite in order to determine what cotangent is. Okay, so we already have adjacent, check. We need to find opposite. Now, what relates to three sides of a right triangle? The Pythagorean theorem. If we want to use it in the trig format, the Pythagorean theorem is going to be the adjacent square plus the opposite square. A squared plus b squared equals the hypotenuse square c squared. Okay, so h squared. Now let's go ahead and solve for the opposite. So adjacent is 14 square plus opposite square equals 16 square. 14 square is 256 plus the opposite square. Actually, I got that reversed. 14 square is 196 and 16 square, that's 256. All right, so we're going to go ahead and subtract 196 from both sides. And that gives us a whole square value of 60. So let's find the square root since we need opposite isolated. So this implies that the opposite is equal to the square root of 60. Now we have to reduce that into its simplest form. So if we want to break down 60, let's extract prime factors. So we can take out 2 since it's even. That leaves us with 30. This is still even. Take out another 2. That leaves us with 15. Take out a 3, and you have 5. Now we're going to look for factors that repeat, because when we take the square root of repeated factors, we just end up with one of them, okay? So we have 2 times 2 repeated. The square root of 2 times 2 is 2. All right, so root 60 becomes 2. The square root of 2 times 2. 3 and 5 do not repeat, so we'll just multiply them together and keep them as a radicand. 2 rad 15. Now we know that our adjacent from the given figure, the adjacent is 14. The opposite, we just determined it to be 2 root 15. So what is cotangent theta going to be? Cotangent, we indicated earlier, is adjacent over opposite. So cotangent theta is going to be 14 divided by 2 root 15. Okay? Now, you notice that you can divide the numerator and the denominator integers by a greatest common factor, namely 2. So divide top and bottom by 2. So you have cotangent theta equals 7 over rad 15. Now, since you cannot have a square root in the denominator, we have to rationalize that. So times top and bottom by rad 15. You have 7 root 15 over 15 as your final answer. And we see that our answer is option letter A for number 7. All right, let's take a look at question number 8, the last problem in this review installment. Let's see. We're asked to find secant theta. So let's rewrite SohCahToa again. Now the question is, which trig function is secant related to? Sine, cosine, or tangent? Secant is a reciprocal of cosine. All right, so if cosine, according to Ka in SohCahToa, is adjacent over hypotenuse, that follows that secant, its reciprocal, is hypotenuse over adjacent. Okay? All right, so we're going to apply this equation to this triangle to determine what secant theta is. We are going to label. Let's see what if we have everything that we need. This is the angle right here, so the side is going to be opposite. The other side is the adjacent, and this side right here is the hypotenuse. In order to find secant, which is hypotenuse over adjacent, we need h and a. We know a, we don't know h, but we can use o and a to find h. The formula that relates all three sides is the Pythagorean theorem. The trig variation is a square plus b square. So adjacent square plus opposite square is equal to the hypotenuse square. All right. So the adjacent is 8 square plus the opposite, 4 root 5 square is equal to h square. Okay. So 8 square is 64. Now what is 4 root 5 square? What on earth is that? Well, let me show you how to multiply that type of number. So 4 root 5 times 4 root 5, you multiply the integers, so 4 times 4 is 16. And then you multiply the radicals, root 5 times root 5 is root 25. All right, so you have 16 times, what is the square root of 25? Simply 5, okay? So don't forget, when you're squaring um, an integer times a radical, you're going to have to square the integer and then multiply by the square of the radical. That's how you do it, okay? So you end up with 16 times 5. 16 times 5 equals h squared. So we have 64 plus, what is 16 times 5? That's 80 h squared. And then we add them together. H squared is equal to 144. And then you take the square root of both sides to get h isolated. All right, so if we take the square root of both sides, on the left side we have h is equal to the square root of 144, which is 12. Okay, so that's your hypotenuse basically. Now let's go back to the formula. Secant is hypotenuse divided by adjacent, so secant theta is going to be the hypotenuse, 12 divided by the adjacent, which is 8. Now this ratio can be reduced, so we just simply divide by the GCF, namely 4. Divide top and bottom by 4, and you have 3 over 2. Final answer is option letter E. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial beneficial to you, give us a thumbs up. We appreciate the positive feedback. If you have any questions about any content of this video, just place your question in the comment section below, and we'll be glad to assist you as soon as possible. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day.